We're going to go ahead and start. I want to bring up this email I got. We were talking about yesterday that we're updating the Guide.which requirements. And one of the things we wanted was if you guys have any ideas, things that we could do to improve or update it, then send us an email with your suggested changes. And when I was introducing the changes that we have made so far, I mentioned that we'd added a new rule 40 dealing with decimals and then we talked about figures. And so this person sent an email saying, based on that, what about how do you deal with fraction? 1/6 rounded off, how do you treat the decimal points for that? That's a good addition. I thought we hadn't thought of before, but it's something we can add to that rule. And so that's what we're looking for in log is today we go through all the individual characteristics. So if there's something that you think we could add or we need to change or something like that, send that email, performance-leaders@cosi.net. So again, today we covered some key parts of section 1 of the Guide to requirements. Today, I'm going to focus on section 2, which is on characteristics of form needs and requirements. That is the overall outline of it. 1.5, why use a text form of communication? And so that goes into detail what the advantages are. In the needs and requirements manual, we have both a discussion of the advantage of textual versus using models to derive that. Pros and cons of both. It's really two sides of the same coin. Neither is sufficient. Both are necessary. In this guide, we're focusing on the textual form of requirements. If you want to use another form, then at least you would expect that form to have the same characteristics that we're going to talk about here. And there's reasons for each characteristic. So for each characteristic, the way the Guide to requirement is written, we have a definition of what we mean of the characteristic, rationale why that characteristic is needed. Then we provide some guidance to help you meet that characteristic. Then we have a trace to the rule in section 4, rules that help achieve that characteristic. We have a trace to attributes to help that characteristic. And those attributes are defined in detail in the needs and requirements manual, but we've added a one sheet listing those attributes and their names in the appendix to the Guide to requirements. So you don't have to be going back and forth. And then a big change from past versions of the Guide to requirements is this traced activities concept of these requirements manual. In doing that tracing, I listed the paragraph numbers in the manual. That's a new thing. So we're saying that to achieve the characteristics, the rules help, but they're not sufficient. They're necessary, but not sufficient. Mike, you mentioned yesterday something about first principles. Can you elaborate on that?
If you consider that a requirement expression is an element of a set, and that set is contractually binding, then it follows, and particularly since we verify each requirement, that each requirement should be contractually binding. So then, if you follow that argument, then each requirement expression should be a mini contract in and of itself. That is, it should say what's needed, how well it should be performed, how it's going to be verified. And so then that's the little mini contract. And if that's the case, then the characteristics of that contract need to be the tenets of a fair contract, at least as they exist in common law, or anyway, in English common law. A contract's not fair if both parties don't understand it equally. And so therefore the requirement statement has to be unambiguous, that it has to be singular. It's got to be a single contract which is being undertaken, at least be able to be broken down to be atomic, that it has to be feasible. It's unfair in common law for me to contract with you to fly at the speed of light, knowing that that's impossible, even if you're dumb enough to sign up to that. So in common law, these characteristics are effectively derivable from first principles, if you like, that if that requirement expression is to be a fundamental element of the contract, whether it's a soft contract between one part of an organization and another in terms of the developer and the stakeholders, or across an adversarial contract between a customer and a contractor, it's the same principles. Does that make sense?
Yes, thank you. That's what I was looking for. And so again, the dependencies and apparent overlap between several characteristics, we see, like if it's ambiguous, it's also not verifiable. When you look at a given characteristic, this is what it looks like at the definition, rationale, the trace to the rules, trace to attributes, and the trace to the sections in the needs and requirements manual that help contribute to that. And then like Mike was talking about in the definitions and requirements, we had two different things included in the definition. One was that the result of formal transformation from something and they were agreed to obligation. And that's what Mike was referring to in the contract part. And so there's certain characteristics that are characteristics if you did the formal transformation right. And then there's other characteristics that are more aligned to if it's an obligation. So I'm going through these in the order listed here and in numerical order. So necessary, the need statement or requirement statement defines an essential capability, constraint, or quality factor needed or required to satisfy a life source or parent requirement. If that isn't true, then we say it's not necessary. What are the risks of having requirements that aren't necessary?
Gold plate.
Okay. So if I have Gold Creek and I put in requirements or gold plated requirements aren't necessary, then what's the cost project?
Increasing cost.
Yeah, big thing, cost,
And
schedule.
unnecessary design space constraint for solution.
Oh, yeah, that's a big one.
So is this different from, say, essential versus non-essential classification of the requirement statements?
We include the word essential as part of the definition for necessary, so
Right.
you may have different language that communicates the same thought. From an essential standpoint, we have an attribute called essential and one attribute called priority. Essential is a requirement defined as one that you can't do without, or you can't meet the use and purpose of the system. And that's different because priority is kind of the eyes of the beholder, but essential is something that's not really negotiable. And ideally, you'd want to make sure that all essential requirements are included. So when we talk about the rationale, if the statement of review is not included in the set of needs or set of requirements, there's a deficiency in capability or characteristic that will exist and cannot be fulfilled by implementing other needs and requirements in the set. The corollary of that we talked about is if you have a requirement that can be met by implementing the other requirements, then why do you need that requirement? Of every need and requirement requires resources, efforts, cost in the form of development, review, management, design verification, design validation, all the different things. By the existence of the shall statement, the costs associated with that. I program where we were developing the requirements. There was a big team involved in, formed by committee, putting all the requirements in. After about 8 months, the program made some changes and it resulted in us having to delete a considerable number of our requirements from our document. And I got to thinking, if you look at the man hours that were taken requirements the last 8 months and the hours we spent talking and discussing those requirements, that each requirement probably represented $10,000 or more just in all the effort and everything. So by having too many requirements, it really does increase costs, and that's a good thing. Heinrich was talking about, he'd like to let's have a discussion on reducing the number of requirements and requirements.
So what's guidance on objectives? A lot of customers will come in with requirements and objectives.
How do they frame the objectives and what do you see?
There's a variety of ways. Some of them are you're given one particular function with a specific performance associated with it, an objective of a higher level of performance.
Like a goal?
Like a goal, or there may be a feature that if you can add as an additional feature.
Do you get extra money?
Well, that's the thing. Depends on, are we talking an external from a defense contract or a defense industry where, yeah, you price it as an additional cost versus an internal stakeholder that says, oh yeah, it's got to do this, but we really like it to do this, and we have the manpower, we want to keep it, but we don't always track it as objective.
So that sounds like they haven't done their job and they're looking for you to do it.
Not necessarily.
Can you do a little extra?
Or we could expand the market just percent if we can include that.
I wouldn't do it in terms where it falls apart. I think if you're incentivized contractually and or way to do more, you have your minimum bar but more. I could see that being a mechanism, but to your design teams, I don't know that it would do anything other than confuse them.
What if the objective of the environment, within the environment? I've seen that a lot. Another way of communicating that is use for a goal, with the goal instead of the objective. But I've seen a lot written like the system shall have a performance of X with an objective And in some cases, used is when it went out for tender, then the contractors, someone bid the X and someone bid the Y. But then that Y became the shell state. Because they committed to it, so now the government's gonna hold them to that objective number. Part of it is, what's the technology maturity that would require to get that performance level? Some contractors may have perfected that technology, and so they'll bid the Y. Others do the minimum necessary to bid the X, and then the government has a differentiator now from a technical standpoint in which contractor they select. So I've seen that.
But from a necessary perspective, do you have guidance from a necessary perspective?
So the objective is not contractually binding. In the document-based world, that would be explained in the front of the document. How you treat objectives, how you treat goals, and the definition of a shall statement is the shall is binding and will be done.
I understand all that.
Yeah.
It actually does rather depend on your execution strategy. So, for example, if you were to tender with some latitude, then you might use your attributes to say, for example, that the system shall pick something 100 essential, 110 desirable, and 120 highly desirable, or provide some function or some graph as to how the customer values that particular requirement. And then when the tender is bid, they'll bid. So I use the range 100 to 120, they'll bid 105. And then the customer has a choice. They can either sign them up essential 105, and we would keep that as an attribute. So you'd have in the database 3 attributes, what was originally offered or requested in terms of range, so 100, 110, 120, and the final contract would bid 105, and that would become the essential requirement. So you could then do your verification against 105. Or in a value management contract, you could recognize the 105 as the bid, but then provide some value for 110 and 120. So the contractor could get the contracted figure for 100, or they could get a 10% bonus for getting to 110, a 20% bonus for 120. So what you do in your requirements really does rather depend on how you intend to manage the contract and whether or not you intend to give contractors a stretch target or whether you would like them to just be verified against the amount that they actually bid. If it's COTS, of course, then it's against the figure bid. But if it's a development contract, then you might want to include stretch targets, recognizing that the project has to have the budget or contingency to be able to invoke those requirements when they come in. Does that make sense? We should show that Wright Brothers specification, which was the first value management contract. One requirement, fly at 40 mile an hour across the ground or whatever, but a bonus was given for extra mile of speed across the ground by the actual contractor. So it depends on how you want to contract, is my point. As a requirements management tool, actually, it's very strong in being able to support. What we could do is keep what the original preferences were in terms of essential, highly desirable, and desirable, what each of the tenderers bid, and then what the contracted figure was, so that you can trace back later on the contract to say, look, the contract only did 104. Do we really care? Well, not really, because our essential requirement was 100. So we might be more gentle with that verification if the essential was only 100. It depends on how you want to go about managing the contract.
Yeah, and I've been through all these situations you described across summer programs. Just wondering if the guide to writing requirements here addresses that, so we're not having the tribal knowledge that may go away, or if we've captured some of that discussion.
I was thinking the same thing. Should we add something in there about just what we're talking about, specifying here's essential value, but here's an objective that's better than that?
So I think we should address it in the priority attribute, but actually it's really part of the guide to managing needs and requirements. It's not so much how you write it, it's how you intend to use it. The attributes are there to manage, so you can include any attribute you like for the purposes of managing. So for me, it's more about managing the requirement set than writing the requirements, if you know what I mean.
Yeah, I tend to agree.
Increase in performance versus an added capability.
Yeah, the government program I've seen it very common that at the system level, requirements will have a threshold and objective values, where the threshold is the minimum performance that the system has to meet. And then the threshold is some additional capability that you'd like to have. But the actual contracting happens at a lower level, like at a subsystem specification level. And then at that level, it's up to the government organization to decide if they want to incentivize the contractor to meet that additional or towards that additional capability beyond the threshold.
I wrote a blog a while back, now that you brought up the threshold thing, that talks about that. That's a good discussion. There is a place we can put that.
One more comment too, that which is why we might not be able to put it in a guide to writing. It might be more in the managing. Is it actually relates more for me to design space, that whoever writes the contract can't specify points for all up weight, for number of passengers, for number of bags per passenger, or number of kilo luggage per passenger versus catering versus whatever, because in the end you might not be able to fit that number of people with that amount of baggage on that aircraft of that length that lands on that class of airfield, etc. So there has to be some latitude at every level of contracting to set a minimum threshold, but to provide a design space above that. Otherwise, it's a multidimensional design point that people who are writing that requirement set are defining, and it's going to be almost impossible to meet that design point. So their obligation is to allow a design space to the next side over. In Australia, we contract for a fixed price at the system spec level. The US wouldn't do that, as we just pointed out. It would be done at the subsystem level, which allows the design space to mature. But it's an issue more for the way in which you use the requirement set rather than how to write it. But we could make some comment, I think, in each of the attributes or each of the rules. I'll make a note, and we can look at that on the way through to see if we can't make some comment about how the set would be managed to do that for priority, for design targets, for stretch targets, for trade space, etc.
I know the NASA System Engineering Handbook does talk about the concept of thresholds and stuff. So requirements not necessary, not needed in sets, set requirements. The requirement can be removed, and the remaining set will still result in the entity that needs to be satisfied. The intent of the needed requirement being met by the needs or requirements. And then another thing is a needed requirement is not necessary if the author cannot communicate a valid reason for the rationale for the needed requirement. You can't justify its existence in words as you write it, then why would you include it in the statement?
I just wanted to ask the people in the room and on the call. So in your own domains, do you always have rational accommodator as part of your requirement as a good practice?
It's a good practice. Does everyone do it?
Yeah, that's
No.
everyone's, that was a question.
Every program I support, I make sure they do have rationale.
We have rationale.
Is that an optional field that you have? It's
No.
like mandatory things.
Something else that attribute rules.
Yeah. So the whole set of attributes that we define in any of the requirement management tools allow you to define attributes for each needed requirement statement. Some of them have some built-in ones, like a rationale, I think, that just comes with any of the tools.
They're not always programmed for mandatory. It takes extra effort for companies to do that. Sometimes it's more people process mandatory, like I see you didn't include it, you need to. But not everybody does that across the board the same.
Okay, just curious, is it just me or the
No.
rest of the?
Just like when we were talking about yesterday about numbers, and someone says 2.00. One of the things in rationale that I always teach everyone explains the source of each number. They got to tell where that number came from. You don't want to copy and paste something from a program years ago.
Lou, if I could just interject for a second, because I'm looking at the NASA system that says the rationale for threshold and goal documented with the requirements to understand the reason and origin for the performance requirement to change. This one is specific performance requirement.
Okay.
Yeah. So it's actually a part of the NASA system.
Some guidance. You want to include only necessary needs and resulting requirements in your requirement sets. Once each need and requirements is proven necessary, the set of needs must then be sufficient. Solution for the agreed to life cycle concepts, the set of requirements must then be sufficient to realize the set of needs. You can have necessary requirements, but it may be that ones you have aren't sufficient to meet the intent of the higher level parent requirement or the need that they were transformed from. And so then you're missing the necessary requirement. Okay. Another thing besides the rationale that shows needed and necessary is you can trace the requirement to whatever the source is where it came. The traceability is really important. If you can't explain the reason why requirement, you can't trace it to where it came from. Again, why is it in the set?
Okay, so I want to hit one of my favorite topics that people always hit about this time. Orphans. Well, I can't find something in that higher spec, so it's an orphan. What do? My approach is you're tracing to a source. It's not always that particular customer spec or something that was given to you at a higher level. It could be a source that's an integrated need from your company's derived set of needs. And so there is a source out there that sponsored that. There may be a mathematical analytical thing that came up with the performance aspect. There's some source out there. Trace to your source. Don't us about tracing to a higher level. That's the part that I have a lot of folks come. Orphans are terrible. Well, you don't. In the sense of there's no source at all. Extra, it's gold plating. It's not necessary. But if you trace to something, it's not always the higher requirement. It's a source. I just wanted to elaborate on that.
There's multiple traces that you may have. In the past, everyone was really big about parent-child relationships. And so every requirement had to have a parent. If you look at the whole approach that we have for each system of interest, there's life cycle concepts, needs, requirements that you can trace to. But if there were allocated parent requirements, then you'd also want to trace to them. So some requirements may trace to.
So when you say source, system element, can a requirement at the system element level and trace to?
Well, if you look really deep in everything we're having here, you define lifecycle concept, needs, and requirements for every part of your architecture. It's not that's just done at the system level. So in that case, for every piece of that you write design input requirements for, you a trace to a need, you can trace it to someplace else it came from. But there is a parent requirements in response to trace to it too, because whoever owns that parent needs assurance that that parent's been met.
This is where we find a lot of missing elements have occurred over the years. Is everything is viewed at the system level, and below that the thought is it just comes from that. But what we're advocating is, especially as you've got maybe different teams, doesn't matter if it's different companies, different elements of organizations are working at these different levels. There are needs and life cycle concepts that occur at each of those levels. And so an organization may get something from a higher source, a system level, and then recognize they have factors they need to account for in their design, development, production, and test. Interfaces. There are other driving sources of needs. Maybe they have product line considerations. Maybe they have manufacturing considerations. And those are your integrated set of needs at your level. And they aren't necessarily dictated from a system level. Sources that drive some requirements in that set and a lower level in the hierarchy.
And I'm going to get to that. I have a drawing that really illustrates that.
Sometimes the ordinance can indicate that you need to create a parent requirement to cover that.
Well, you're right. Sometimes you want to tell your customer you missed something. I think I've seen that before. Sometimes an orphan is an indication of, we forgot to do our needs process. We knew this needed to happen, but we forgot to really understand why. Really do that due diligence.
And one thing that really hurt me is I asked the location once, and they had a training course by a doors instructor, and he introduced to them the self-derived requirements.
Self-derived, what was that definition? I mean,
Requirements that you know need, and it doesn't matter if you have a parent or a source or anything, you just know from your knowledge you need it.
Just know you need it.
Just because you think it's self-derived. It didn't drive from anything other than
I just know it.
you think. Yeah.
Those sometimes are derived from lessons learned that should be documented, or something out there, or some rules, some regulations, something. They're not just driven because I feel like it.
Yes, we agree with you.
Yeah, we agree with you. And then along with that, he had self-allocated requirements.
I love that. I'm just whatever requirements.
No, it's I don't care if anyone assigned me that requirement. I'm gonna.
That's all. Don't do that. Okay.
No, yeah, no.
We're not really.
That was actually being taught, in the course, and then I'm coming after. No, that's not right. Okay. That some organizations take is limit the number of design input requirements, take zero based, and then it's also the concept of minimum viable product, to help limit your requirement set that people use. I know the original crew exploration vehicle, which is now Orion, it had such a bloated set of requirements, there's no way they could meet any of them as a set. And so they had to throw them all out pick out really the essential, and if you wanted to add anything else, you had to fight. You had to come ready to get the boxing ring and fight to add that requirement to the set, because it got so bloated, it had no filters. They just accepted requirements from anybody that had a requirement.
I've
Yeah.
seen that in action, unfortunately.
Yeah.
It was the idea that your stakeholders are also your SMEs and your smart people. And remember that example of the doctor and thought we had a hospital on the space station. It was
Yeah.
like, we all know what we need. We're just gonna throw that all into the requirement space without any due diligence of the project constraints.
So we did a little something. We wound up with mission critical. Mission fulfillment requirements. The mission critical is going to be protected the health and safety of the employees. The essential requirements for the ones that will allow you to at least get the data down and archive and store it, which is the purpose. And then the fulfillment ones were basically being able to do some higher level gold-plated processing. Didn't see in the picture of that.
That's what some people include should statements for goals.
Yeah.
In the requirement sets. Post rationale, again, the other attributes is going to help you. And so rules that contribute to the necessary characteristic. Attributes contribute to the necessary characteristic. And then all kinds of activities that are discussed within the needs and requirements manual contribute to the necessary characteristic.
Up in section 4, we talk about use of diagrams and models for analysis. So is there a current effort to collaborate with the MBSE and the architecture teams to determine how we have an approach to tracking like functions through the overall SE analysis function and the functional architecture that
was raised as a topic. We don't actively have that in work now. The concept of finding some standardization there has been broached. And certainly some of the discussion topics we've been asked to have is better or introduction to requirement modeling. What are the out there? And certainly we aren't experts in that. And that is an area to have a further discussion on.
But when talking, certainly define the needs, and the needs we said concepts. So any of the modeling that you do as part of that analysis could result in those needs. Unfortunately, right now, SysML doesn't recognize the concept of needs. You know, they don't have an entity type of requirement. They don't have one for needs.
Right, you just could build in a stereotype if you have to, right, for those that speak that language. But I will tell you, it is less interesting to me to talk about how do we do this in the model. For me, the more interesting thing is we have these techniques to understand our operations, our use cases. And from that, we have modeling tools that enable us to understand our functions. And then we can elicit or derive our needs from a lot of those. We can put them somewhere. So I speak to the abstract. I know you can do these in modeling tools.
Yeah, and I'm not advocating that we follow a prescribed method from a tool, but the tools are implementing the modeling capabilities we used to do in Visio, PowerPoint, or whatever. And so we're still following the same SE fundamentals and building an architecture, doing the design, developing the requirements, and doing that triad. So whether we're doing it on paper or within the MBSE tool, it should have that same basis for justification for the functions, the triggers and the conditions and all that.
I agree 100%. We've not investigated the modeling techniques since.
A lot of that processes are intended to be done concurrently.
Right.
And so the architecture team should be involved in lots of the concept definition thing. And the design team too. You know, you got to determine feasibility. Out of all that analysis, then comes this integrated set of needs. So that's what we're saying. The integrated set of needs has an under analysis to help ensure correctness, completeness, consistency, and feasibility. And some people practice really model-based design. You give them a set of requirements and they develop models for that requirements. We're saying modeling starts at the beginning. You can start modeling during the elicitation. So the next one is appropriate. The intent, amount of detail, need, requirement saying is appropriate to the level. Level is level of abstraction, organization, or architecture. So you got to be careful what level you're talking about. And then of the entities, which it refers. Remember the talk I gave yesterday about entities. and the importance of entities, because I have requirements on factor, on a project, on a person of interest, on a procedure. So we got to make sure that it's appropriate for doing that. So the wording of the needs is often stated at a higher level of abstraction. Needs and requirements, I think, level of organizational system architecture, however, as a rule, a needed requirement should be expressed at the level of the entity to which it refers, must be able to be verified and validated to have met that needed requirement at that level. And I don't want to have a subsystem requirement shall statement at the system level, because I can't verify, probably to verify that requirement at the system level. I have to do it at the subsystem level. Requirements for lower level entities stated within requirement sets for like implementation, some of that we were talking about earlier. So if I have requirement at the design level, some people say that's how. That actually when you go between levels, people say you're going what, how, and there's a paper written about the requirement sandwich.
That was Jeremy Dick.
Jeremy Dick wrote that has that philosophy. And conversely, higher level entity requirements stated improperly at lower level entity set requirements can be problematic because they may not have been allocated properly to other entities at the next level architecture. So if I ever have a requirement, I'd specify it at say 3 levels down, that it really applies to multiple entities at that level. It should have been expressed at the previous level, so it could have been allocated to all of the pieces that had a role in it. So this is the diagram showing, so we have different levels. The first level is at the organizational enterprise level, the second strategic level view, business operations level. So those are all levels of organization. And then below that, then you have a system level, subsystem, system element. You want to make sure you're at the right place when you're on those requirements. Especially at the business operations level, some of those requirements may apply not only to the system of interest, but to the organization. So we got to separate those out. The hierarchical view, and I've heard multiple times, advantageous, divide and conquer, break it into pieces. It's also a problem when it comes to taking a holistic view and interactions. Because notice this drawing doesn't show any interfaces, doesn't show any interactions. The architecture tends to mirror the architecture of the organization. And that's where these things are historically stuck in silos because the way the organization is set up. We have different levels and we got to be careful, understand what those levels are and put the requirements where they belong. The current Guide.which requirements doesn't have these figures in it. So we're adding the figures of the text that go with them to help more elaborate these characteristics. So guidance, unless there's a good reason, the subject of the needed requirement statement should be referred to the entity at a level. So the subsystem shall requirements go. So if I'm talking about a power subsystem, I should say the power subsystem shall. If I'm talking about some other subsystem, it's going to be that name shall. So just by looking at the entity name will help you understand what set that requirement should be communicated in. Design input designed to what requirements must not be any more detailed or specific than is appropriate for the level of entity in which they're stated, not the how requirement. And that's what I took from the medical device world, the concept of design input versus design output specification. Because one of the biggest problems people have is people throwing in design output level of information into the design inputs, the implementation. By clearly saying these system requirements are design inputs, it says we shouldn't contain any design, just inputs into the architectural design process. And if you do put in a how, then that's a constraint, and you definitely want to have rationale why the customer or whatever is constraining you to that one implementation. And there may be a good reason for it. Like Tammy said, reuse. We want you to use this. We already have a power subsystem. It's using 15 different systems. We don't want you to build another. This is the design input requirements should avoid place unnecessary constraints in the design. We don't bring innovation. Again, the goal is implementation dependent. And then the use of question asks the requirement for what purpose or why. If it is actually implementation, the answer to why is probably what the real requirement should have been stated. We have the design inputs, design outputs, and so we're really trying to focus on inputs, design output specifications. forms, and we're not really addressing those requirements. We focus on design inputs. So the line dividing between design inputs and design outputs. So when you're in a discussion or in a meeting, you start to talk about something. That's a good idea, but you talk about below the line. Today, we're above the line. Don't get into that design implementation. So common issues, design input requirements that show implementation we're talking about. And then when design details are stated as design inputs, there's often no definition of the why. I see that in some standards where they actually specify the standard, a design, that a mechanical drawing, but they never have rationale for why. The real design input requirement that that's in response to is not communicated. And one big problem with that is it may be if I knew the why, there's other parts of the system that may be impacted by that should have been allocated that requirement also. But by avoiding that, the resulting child requirements are never written. That's a problem.
I have a question kind of related to that. Let's say we have a legacy system and you're writing requirements for the next generation of it, right? And most of the subsystems are going to pull through as designed into the new system, and some of them will be changed. So those design decisions have been made programmatically. Would you consider those as design constraints that you would put into the requirements?
If you look at this diagram, you notice the different colors. Some people think that at every level, everything at that level has to have requirements. And if you look at what this says, the pink ones say there's concept needs and requirements for it. We do analysis and then we determine that we need to do further decomposition. So we go down to another level. For some of these, the green ones, the system element, no further decomposition. So in your case, here's the requirements, and someone said, well, we already have a power supply that does that. Why define the requirements for the inside stuff? I already have them. In this case, this decomposition I did to that subsystem resulted in breaking it up into two, what you're saying, two system pieces. So I just stopped there. I don't do any further decomposition. Remember, when you're flowing down, you're going down until you can make a buy, build, code, or reuse decision. And as soon as you make that decision, you stop. Thanks for bringing that up.
You capture that decision as a requirement at some level.
But it's at a project component, so the system component.
So for referring to the entity at the level of requirement, do you think in system level requirements that every requirement should say the system of interest shall?
Whatever its name is.
Yeah, the system shall. We've been trying to be pretty strict about doing that for certain things like maintenance and documentation and training. It gets awkward because the system isn't actually doing that.
So they shouldn't be in there.
They should be in the statement of work. Somebody has to do the maintenance, someone has to do the training management plans. So there should be a statement of work placed on, whoever it is or whatever entity it is, someone shall. So that it's a good example of how it's a common indicator that you've actually got the requirement either in the wrong place or poorly expressed if you can't start it with the system shall. There is a qualification though. For example, if we were designing an aircraft and wanted to use a particular Rolls-Royce engine because it was the one we had on our previous aircraft, the business might actually have in the system spec, it might refer directly to that subsystem. But these are exceptions, right, rather than the general rule. So any statement appropriate to that level without starting with the SOI at that level.
So this is required to have documentation, operating procedures, things like that, but that should not be in the system requirement specifications.
It's a deliverable or it's a requirement on someone else to prepare that documentation in accordance with a certain standard, someone else to verify it, someone else to. So it's a completely different set of entities. It's not the system that does that, verifies it, or any of that. It is possible and reasonably common for there to be a maintenance spec. So you can say the maintenance subsystem shall, or indeed even the training manual shall, if you would like to refer to that as an entity. But you can't say shall prepare or shall do. Like the function has to be performed by someone who's doing something. But you could talk in a subsystem specification about a maintenance manual or about a maintenance process if you wanted to do that.
You usually have reliability, maintainability requirements derived from how you're going to maintain. So you'll have mean time to repair, numbers to meet between maintenance, unscheduled maintenance, availability, type of numbers of those requirements against the particular item. But yeah, the other things. That would be in the document.
But those are characteristics of the system as designed.
Right.
If I have a maintenance procedure as a deliverable, I could have requirements on that procedure. In that case, that would be documented separately. And just like medical devices, they have a thing called instruction for use. And the requirements would go in instruction for use are documented separately from requirements on the system of interest. Now, it brings out an interesting question is how do you define the system? So I've seen some people, like for medical devices, they have this overall medical system that consists of labeling, instructions for use, package, and the system itself. And they'll define all those as a macro system. In some cases, the system has set requirements, and then they're going to be allocated appropriately to those at that next level of architecture. The requirements for an architectural element should apply just to that entity. And so it's kind of how you architect things. But once you do it, and if it really is a requirement on the organization producing the product, it should be in statement of work type document. Or in-house, it might be in a project requirements document or something. But they're all project shell requirements.
Yeah, so I was a bit surprised to see system of interest here at the bottom. And I was expecting to see system element at the bottom, which would be specified by the design output specifications. And I was expecting to see system as being specified by design input requirements. Is that wrong, or how do you see that?
Well, the system of interest is anything your team is building.
Sure.
And so it's going to be built per a set of specifications.
It's something we should be consistent with, though, Lou. It's a good point, Brito. It's slightly annoying to me because in ANCOSI, the generic view is that everything is a system of interest.
Sure.
Any two elements connected together. So a nut and a bolt is a system. It's a fastening system. You know, the nut and bolt connected to is a system. So everything is a system of interest. But it's not helpful when you do that. We might go through, Lou, and see, because it does become confusing to keep going from the system of interest at one level to the system of interest at the next level, because actually it would be systems of interest, if to be correct, if you wanted to do that, if you know what I mean. I would prefer system element, to be honest, because it's a subsystem, you know, it's a...
So in reality, to be consistent with this drawing, then the design output spec applies to the system element, Mike.
Yeah, I think we should be, even if we're internally consistent and not quite consistent with ANCOSI, I would prefer this view. If you keep going system, the use of the word system becomes nonsensical. Everything's a system, as long as there's two things together. I think Bruno's correct. The next diagram really should be a system element rather than system of interest coming out of the design output.
I have a question on the previous topic about the role of information items like documents, if they had to be placed into requirements specifications or in the statement of work. And if I take your example, Mike, you said, for instance, that in a statement of work, the description was the work is provided, like the supplier shall make a training to the customer, introducing delivered end product, or describing there should be 3 meetings and so forth, and monthly reports delivered by the supplier and so forth. So that's clear. Where I have some doubts, it's about the role of information item like a user manual. And I know, for instance, that in aerospace, these kind of things, for instance, are not included into the product breakdown structure. So they are not part of the delivered product. My personal thought is that are they needed in order to operate properly and safely the delivered product like a machine? I would say yes. So they are characteristics of the delivered product. So if I take that perspective, I tend to place a kind of requirement. The system shall be read, and then it's the characteristics. And similarly, the system shall have a user manual. So it means that it should come with a user manual that should help the operator to operate that machine safely and properly. Is that view correct or not?
So I think it's unambiguous really about what's actually required, that there should be a manual, but it depends on the execution strategy. So in the US, I think, and in Australia, we would have a view which is slightly higher, which is of the capability. So we would talk about it as a capability system. And then that capability system would include people, processes, products. And one of the products would be the end product, the system, if you use a 632 term. Another product would be the training package. Another product would be the training manual. Another product would be the operations manual, the maintenance process. So if you decompose at that level, then what we're saying is in the set of requirements that define the end product, it must all start with the end product shall. If there is to be a maintenance manual, then there will be another product, which is the maintenance manual shall. And then there'll be a statement of work requirement on the contractor to develop the maintenance manual. What it does is it forces you to be clear, I think, at that higher level. There's not just the end product. 632 calls these other things enabling products. The US had this idea of DOTLBLF, doctrine, organization, training material, logistics, personnel, facilities. And every one of those would have a spec associated with it. The facility shall, the people shall, the doctrine shall, about the entity which is actually being defined. And then there's a statement of work associated with each, most likely about who does that particular thing. So you see it very commonly, the system shall have a manual, the system shall. And I don't think it's unclear as to what that means, but it would be clearer to say that the capability system comprises these products, one of which is the maintenance manual, and then say the maintenance manual shall, in terms of what it should include, etc. Point though, I have to say, it's not, there's no universal agreement on that. We're working our way up to that.
I think I like it very much because it distinguishes the delivered end product. Like, for instance, when we discuss a car, people just think about, the engine, the wheels, and the chassis, and so forth. And they forget that intended capability will be delivered not only by that piece of metal, let's say, but there is a need of more. There is a need of driver, procedures, manuals, and so forth. So this is why I use different terminology. For me, what you call a capability system, for me, is the system, and then which comprise product, people, and processes. And I call just what is produced and the delivered product. But I think the concept is the same, and I like it very much because it differentiates these kind of aspects.
And the other important thing about it too is it's most likely that in a project, there may well be different contractors. So the facilities, for example, has to be separated out to be the facility shall, because they're going to go off into a facilities contract, whereas the end product might go off to an end product contract, but the training might not. There might be a separate engagement for the development of a training needs analysis or whatever, and the training pack, and then the conduct of the training. So by being very clear about the entity and making sure that it's appropriate to the entity, it's not just the level for me, it's also that's how the project manager is going to contract, how many contracts are needed, all in one or whatever. Yeah.
Thank you very much. I appreciate it.
The architecture, I guess, could start at the customer level, and then they could divide that up.
Yeah, I mean, for me, the good example, when we did the coffee machine, Lou, it's a good example of if they say, straight away it says the business needs the coffee machine to be able to be sold throughout Europe and Australasia. And then straight away somebody has to decide, well, how's that going to work? Like, who's going to get the permission? What standards have to be met? Who's going to apply for those? Who's going to do the legwork to actually run that through the application process, etc. So there's a lot more things have to happen at that higher level than just a set of requirements for the coffee machine. All the other work that needs to be done has to be stated somewhere, either as a statement of work or as an end product. So that's why that 632 view of a system comprising operational products, end products, and then enabling products is a really good view to start with, because the shed load of things that turn up on the project work breakdown structure that aren't in the end product. And if you don't have that view right off the outset, you've missed so much work, it's not funny. And in fact, it's the single cause for me for projects overrunning, because they haven't quantified the work appropriately at the outset. So the scope is inappropriately quantified, which means the budget and the schedule aren't adequate either.
And in wording the requirements, where we say the system shall, that word system has brackets around it to indicate that's just the placeholder name of the entity that the requirement applies to. So you want to make sure that you include that proper name. This actually was in the original Pan Am requirement written for the first passenger airplane. They're going to convert the DC-3 into a passenger airplane. And they said the aircraft shall have 3 engines. Douglas Aircraft said, wait a minute, our existing planes only got 2 engines. You don't just go and throw a 3rd engine in. So why? And so it turned out, well, the aircraft should be in operation with a single engine out, and then you'd have operational forms defined, someplace. And then Douglas said, well, we designed this, the military requirements on the plane must get single out capability to land safely. The system shall include flight performance instrumentation. Well, that's nice, but when you go and say, what do you want to verify? I can verify you have instrumentation, and that it doesn't have to give me any data, you know, but it's there. Other way is, you know, it's got to measure flight performance, and then you're going to define what those parameters are, what it's measuring, and accuracy and precision, and you know, a bunch of other things. But the intent is if you ask why and what do you want to verify of each requirement, you get a better pretty properly. Rules that help establish using active voice, the subject verb, we want to make that real clear, and then abstraction, getting rid of solution free.
Can I just add one thing? Not 80% of the time a fixed passive voice, the subject is actually inappropriate to the set that's being spoken to. When you turn it around, you try and insert the system shell, you say, yeah, that's not the system at all. It's the maintenance package, or it's the contractor, or it's whatever. The forcing of the subject is not just to get the language right, it's to actually make sure you know whether it's appropriate to level for a start, or indeed then later on the verification.
That's a very good point, because I gave the example yesterday about construction contracts. Seeing they'll have included in their requirements on the building, and have requirements in the building, and then there is passive voice. So it's really hard to determine which requirements to the building, which requires to the contractor, activities. And then we have singular. The needs statement or requirement statement state a single capability, characteristic, constraint, or quality factor, represent a single thought, aspect, or an expectation, and the effectiveness of several processes that we talk about, such as decomposition, derivation, allocation, traceability, verification, validation, are really depending upon that you have a singular statement. If you have multiple thoughts in one thing, they may be allocated differently. The verification may be different, that the system needs into those parts. So it's really good to have them all separate. And so the system verification information is going to be more precise, and needed requirement of multiple thoughts difficult to allocate. A non-singular needed requirements neither verifiable nor correct. So keep each need statement, requirement statement limited to one quality, characteristic, capability, function, constraint that is appropriate to level at which the statement refers. Although a single needed requirement should consist of a single function, quality, or constraint, it may have multiple conditions under which the requirement is being met. And so you may have several different clauses concerning condition. Those can be assumed as being ANDs, so logical and. Requirements that invoke other sets of requirements like a standard or a regulation, it's multiple requirements, and we've broken this forever. We've invoked says you should meet the requirements in this standard. The work that we've done lately, that really doesn't make sense, especially when you don't know if those requirements are even applicable, and it violates its whole allocation, verification, and so on. So what we advocated is that as a need, you can invoke a standard, a section of the standard, but then the requirements, you're going to derive specific individual shell statements that meet the intent of the requirements that are in there, and you'll provide traceability to those. We use the word and, which is rule 19, when it ties together multiple thoughts, phrases in the sentence, each of which may be verified differently. And I've seen sometimes the system shall do this, and shall do this, and shall do that. To have three different shells in the same sentence combined with ands. You definitely want to do that. Sometimes they'll leave out the shells and just tie those multiple thoughts together. And so we want to do that. There are some exceptions to use of and. Some organizations use and to join two actions that always be allocated, traced, verified, and validated together. For example, lit match has to be extinguished and disposed of, and you're always going to do those two actions at the same time. Then maybe it's okay to do that. So the organizations have to look at the cases, see what makes sense, and be consistent. In a case like the multiple conditions, everything, maybe you have a logical and, so that within the parentheses of the stuff, it condenses down to a single true false. So it's a
even then, though, you can confuse the conditions as to which aspect they apply to it. The way it will naturally extinguish any disposal.
True. Patterns or templates are also useful ways to ensure singularity. And we talked about patterns in appendix C, this is section patterns. We want our needs and requirements to be correct as a characteristic. So the need statement must be accurate. The concept is yours, which is transformed. The statement must be an accurate representation of the need source parent requirement from which it was transformed. Correct implies both from the perspective of inclusion of incorrect information as well as the required information and avoidance of ambiguous wording. Incorrect information may have the wrong values, the wrong functions, conditions, other characteristics identified in the requirement statement. Modeling, I think, really helps in that area. At least the functions and conditions, not so much the values. Those are numbers that have to come from a different kind of analysis. An incorrect need can result in a need that does not reflect the intent of the lifecycle concept or sources. It was transformed. Incorrect need can result in incorrect requirements transformed to the need. Quality of the requirements depends on the quality of the needs. So if the needs are defective, the resulting requirements transformed to those needs will be defective by default. Incorrect requirement can result in a requirement that does not reflect the true intent of the need source or parent requirement, which is transformed, just like the need. A need or requirement because if it does not have the unambiguous, complete, feasible, verifiable, or conforming. Validate the needs, communicate the right thing, intent, accurate interpretation, concept, stakeholder expectations, understand the problem or opportunity, underlying goals and objectives, represented the model or diagram from which the need was extracted, representation of underlying analysis and assumptions that were part of that. So there's an assumption here that you've actually did this analysis and you've used models and stuff. Perform needs validation is discussed in the needs and requirements manual, guide to needs and requirements. Section 4 of the needs and requirements manual is defining lifecycle concepts and needs. And section 5 is the verification of those needs. And section 6 of the needs and requirements manual is defining your design input requirements. Section 7 is focused on the verification about the right needs in there, they communicate the right thing and they're formed correctly. And the guide to requirements, Tammy's included checklists in the appendices to help do these things. When we talk about the integrated, the validation is against both the lifecycle concept and also the other source that may have came from. So the problem or opportunity that was defined at maybe at the business level, mission goals, objectives, measure defined at the mission level, stakeholder real world expectation communicated in the form of stakeholder needs or stakeholder requirements, use cases, user stories, system concepts, ops, ops, higher level requirements allocated to your system. A lot of work here to do that validation, but you want to validate this, and the big part here is one of the ways you do this is you involve the stakeholders, that are sources of this information. So part of the validation of your set of needs or validation of a set of requirements is to involve the relevant stakeholders. And if you're trying to validate that it communicates the true intent, who knows that the best? But the stakeholders that actually have those expectations. And so guidance, validate the achievement of the requirements as a regular result of the intent of the need, reflects accurate and unambiguous interpretation of the need, source, higher requirements is transformed, representation of the model or diagram, and also similar to what we did with needs. One of the big things we're talking about is that you do continuous verification validation across the line. After you have a set of needs, you validate those against where they came from. You have a set of, you validate those against the needs. But then when you're doing design, you're going to validate the design output specs against the needs also.
I think with the projects that I've worked on, I think it's very important to have your integration test engineers involved in writing and reviewing the requirements, so that will help ensure that verifiability is part of the requirement.
Absolutely. And that's part of the concurrent nature of things, is we don't throw over a step to them and say, can you do system verification? They should be involved up front.
Right.
And that's another reason why those are attributes of our needs and requirements when we write those.
Absolutely.
And I'll talk more about that. We have a characteristic verifiability. So a similar drawing, in this case, the design input requirements are going to be validated against that integrated set of needs. And the design output specs that we were talking about, they would be validated against rules that help ensure that's correct from a wording standpoint, attributes that you can define, and this is what we were just talking. So when you write a requirement, you should be defining the success criteria and the method, condition use that's involved, so that you know it is verifiable, validatable. It may be that you need to rewrite the requirement, and we can do that assessment.
As you recommended not to point a requirement statement to a standard, how do you suggest to exploit standards? Copy and paste requirements from the standard?
Absolutely not. So I spent 2 hours talking about that on Monday. That presentation is going to be put on our YouTube channel, and you can listen to it. What you stated is how it's been done in the past, but some of the things I pointed out on Monday was most standards contain information on not only the product being developed, but on the organization and how you're going to test it. And so you need to at least do some kind of a winnowing down of they're on purpose written generic class of products similar to yours, written for yours specifically. And so you need to derive the specific to your system of interest, not copying. That single thought thing that we're talking about is totally violated. The only way to really have control now, admittedly, it ends up being a whole lot of requirements. On the other hand, maybe not. Because if I invoke a standard that contains 100 requirements in it, and only 3 apply to my system of interest, who decides what 3 of those are? And what's the expectations for showing the evidence of which of those requirements actually I have to verify and validate against? The old way of doing this, rethinking it, really is just kicking the can down the road. So we're going to do a lot more detail on that.
So we have cited standards in the past with specific paragraph numbers.
Yes.
Which was a requirements. And then you keep the version in the applicable documents, so you know which version it is. So that's a standard we use for.
Yeah. And the approach we talked about Monday is that would be a need statement. So you'd say the stakeholders need the system to comply with standard so-and-so, section so-and-so. And then the transformation of that into the system. Then the project team is going to do the exactly how does it apply, and they're going to drive specific design input requirements that meet the intent of that standard.
So the system of interest shall comply with this aspect of paragraph, whatever standard.
Yeah, and that's a good need statement. It's not a good requirement.
And that we use them as requirements.
That's how it's been done in the past. And so we're looking to the future and saying maybe that's not the right approach. It has a lot of issues in doing that, especially when one of those requirements calls out another standard, and that calls out another standard. Now you've totally lost control over the whole project.
Oh, you do I mean, you can't blindly do it.
Yeah.
And in a lot of cases, if you go in and interpret that, and you interpret it correctly, you accept some risk of not complying with the intended need of the customer.
Yeah, and I've also got a plan for each one of those, how you're going to verify that the system has met those, and you have to define the individual criteria. And so, unless I state that as individual requirements, I'm not going to have those defined. And also, it wouldn't be a bad idea if you could explain the rank for each one also, and have the traceability to make sure each one really is needed. A little change of thought. I've taught classes just that's how you do it, and now I'm finding out maybe that wasn't the best way to do it.
Well, I 100% agree with that. Because we got handed that problem where the requirement said, shall comply with this standard. And the standard was 500, and it referenced numerous other standards. And there was absolutely no way we could verify that. It was literally impossible. We had to go back to the system and basically get them to listen the real requirements that were contained in that.
Yeah. And I worked with one master program where I brought that up, and so they assigned one of the engineers to specifically actually read
Reading standard.
actually read each standard and each requirement in the standard. And then she invoked only the ones that she felt was applicable. I also talked about it on Monday, a thing called the ability matrix as a way to filter out and which one. And some of the apply at the system level, they may apply through the, so they shouldn't be invoked until the proper entity applies.
Yeah, it doesn't absolve you from going through the requirements in that standard are applicable to your product in the use that you are.
And which level, which entity within your product.
Right.
Yeah. Lots of activities help understand correct and use of the diagrams and models to help with that. Then we have conforming is about statements of expression of individual needs and requirements to conform to a pattern, the style guide or standard for writing and managing needs and requirements within an organization. Our needs and requirements within that same organization, they have the same look and feel. Each need and requirement statement is easy to write, understand, and review. I went to clients where I read a requirement document and I could see the system of interest had 5 different names in the same requirement set in different styles. And you could tell that they had no one standard and there's 5 different groups that were contributing to the requirements. And it's not a good set. So we want our requirements and needs to conform to the approved standard. Forming the standards and templates for needs and requirements to help identify missing information and help obtain the characteristics of complete, unambiguous, verifiable, validatable. Most of the standards are going to have a list of rules that you should follow. Actually, if the organization lists the guide to writing requirements as a standard, then you're going to follow the rules. For the derivation of the need from a life cycle concept to be formal, the structure of the resultant need statement must be formal. The same thing for the transformation of need into requirement. Organizations must have well-defined standards and processes and needs for requirements development management. In our we talk about the transformation processes, the organizational requirements for how the organization is going to do the transformation. Transformation, developing your set of needs, there should be a procedure within your organization work instruction for how you expect people that's followed and enforced throughout the organization. Transforming the needs into requirements, there should be a standard within the organization of your expectations for how you're going to do that. The same thing, how does the organization do design? How does the organization do architecture? How's the organization going to address the format when you're defining design output specifications? Drawings. And then manufacturing, you're going to have a set of standards for how you do manufacturing. So there's a whole bunch of set of organizational sets of requirements. People call those the design principles. And I think they have a document called that all the designers, no matter what spacecraft you're expected to follow that. Goddard calls it the gold rules, how people should do design. And one of the gold rules, I think it was Goddard discovered it, is that one of the first spacecraft that was launched into space, they discovered that when you take an electrical conduit and go 17,000 miles through magnetic field, it just might generate electricity. And so maybe you need shielding.
Moving magnetic field.
And so maybe it would help to have shielding. And so they have basic standards for design. Those things may not be called out in your design input requirements, but they're requirements on the organization on how you're going to architect and design, and maybe what kind of parts you're going to use and stuff will be part of that set of requirements. You can use a natural language processing AI tool to help conform. And there's a lot of tools out there now that do that, but they don't do all the rules. They only do the rules that an AI can do. So when we said one of the things that wasn't correct is to use the wrong number. Well, these don't know if you have the right number or not. They just know there's a number there and it's formatted. So you got to take those. They do help eliminate all the real obvious things, like all the ambiguous terms. They're going to find most of those folks kind of ignore the characteristics. That's one reason I'm focusing on characteristics, is they focus on a subset of the rules. And some do more rules than others. Many instances, there's applicable government industry and product standards, specification interfaces in which compliance is required. When developing needs and requirements from a the customer have their own set of rules. In that case, you got to comply with the customer's set of rules when you're doing that. And the organization approval and baseline processes include verification of the needs and requirements of quality for the organization's defined standard. Part of baselining your needs and requirements is to make sure you've done the verification piece for the standards that we define for how you form the needs and requirements. And this drawing that we have, then is against that organizational requirements for defining needs. And for the requirements, then you have organizational requirements for how you're going to do your requirements. And so the resulting set of design input requirements, you're going to verify that organization followed the rules for writing well-formed requirements. So we have rules that establish this characteristic as far as the conforming. R40 is in red because that's a new rule that we added. Activities that we talked about. Characteristics of these requirement statements that have to do with agreed to obligation. Remember, the first set I did was talking about, did we do the transformation properly? Now, this agreed to obligation, and like Mike said, it's got to be at the individual requirement level as well as the set. So, like feasibility, we have that as another characteristic of the sets, just like we have unambiguous. These same requirements must be stated such that their intent is clear and can be interpreted in only one way by the intended audiences. And each statement, requirement statement, must lend itself to a single interpretation of intent. Statements are effectively an agreement between two parties on communicating intent from one or the other form the basis of verification validation that intent was met. And the agreement is difficult to enact unless both parties are clear on the exact obligation.
I'd say that's actually a lot more difficult than it sounds.
Yes, it is. In section 3 of the needs and requirements manual, we have a section on communications. One of the tenets of good communications is that the responsibility that the message sent is received as intended is in the sender. And that's really important when you go to court of law, because if it's ambiguous, who's the judge going to rule for?
It's the judge going to rule that it's
ambiguous. Yeah, so it's a fault of the customer. You wrote specific requirements.
Right.
And ambiguous need is not correct or able to be validated. Ambiguous requirements not verifiable nor correct. Here's a good example. We have a lady, she comes to the wizard and says, I need a cream for wrinkles. And the wizard mixes up with cream to the lady. She goes happily with the cream. Sadly, a week passes and she's very upset, returns to says wrinkles all over her face. And the lady of the wizard, perhaps I didn't make myself clear. So the key is forming wrinkle to give, remove, or prevent. Depends on your perspective. Just simple words that we use every day, depending on the context, can be interpreted. Here's another example. A woman with long hair to her shoulders comes to the barber and says, I need my hair shorter. I want it over my ears. And the barber, who has short hair, says, got it. And then communication problem. The woman meant she wanted her hair cut, but for it to still cover her ears, barber who has short hair thought she meant she wanted to cut so it's above her ears. So does over mean cover above? The English language or any language worse than me, but I think the word English language is probably worse when it comes to ambiguity. This happens all the time. And the bad thing is that we all assume that you know what I meant without actually verifying whether or not that's true. So the problem is each person's interpreting the word based on their own set of filters, biases, and assumptions. The intent of any need or requirement must be understood the same way for all involved across the life cycle. So the customer and users, the stakeholders are source of the requirements, the people that have to provide the system based on those requirements, the people that have to verify and validate that the needs and requirements are met, they need to look at it all the same way. So it leads to interpretations of the need or requirement. The author leading to problems such as schedule slips, budget overruns, or failure to pass the system validation and not accepted for its intended use. Guidance for needs, ask whether it is validatable. They're stated in such a way that sufficient evidence can be obtained that the need has been met based on the wording of the need statement without having to interpret stakeholder intent or make assumptions. Ask whether it's verifiable, whether it's stated in such a way that sufficient evidence can be obtained that the requirement has been met based on the wording and so on. It's useful for stakeholders who are involved in implementation of these requirements to be involved in the development review baseline. Like I said before, they're the ones that should down, no matter how it was communicated. Use the attribute rationale to help with information, because again, no matter how well we write something, still maybe a little bit question what our intent is. Rationale can help us to clarify it. When text only makes it different, maybe a diagram might be better. And as you refer to a model. Ambiguity of individual need or requirement statement can be assessed during the early system verification, validation activities as well. A lot of rules deal with ambiguity because it's such a big problem.
You could add an additional non-requirement statement that provides clarification or definition, something, right?
That's the rationale.
Well, the rationale is for the reason.
In the rationale statement, you can use. We do have another attribute that title other information that if you wanted to, you can use that attribute. But we don't advise you to have a shell statement, period, and then immediately include with that another sentence. You don't want to have 3 sentences that are called out a requirement when only the first sentence is that shows up. So now we have complete. The need statement sufficiently describes the necessary capability, characteristic, construct, the quality factor to meet the lifecycle concept of source, for which was transformed without additional information to understand it. Same statement for requirement statement. Agreement is not useful unless the obligation is complete. Does not need further explanation. A well-formed need statement needs no further application to implement its intent. A well-formed requirement is the same thing. Functional requirements include performance characteristics to be complete and verifiable. We hate when people say we got functional requirements and non-functional requirements and the non-functional requirements. So it makes no sense. System shall do a function without communicating what performance you're going to verify against. And so I like to say functional / performance. And it may be for a given function, I have 5 different requirements that say the function shall, but they'll have 5 different performance parameters. Each will have a different performance parameter. That is allocatable and is verifiable. And interface requirements should include reference to location of the group that defines that. So typically we'll have something like an ICD that contains the definition. And that's and then the requirements point to that definition.
I mean, wouldn't that be the same thing as like the standards, referencing the standards?
No, in a way, the ICD is a standard,
Right.
but it's a definition of the interaction. So when you look at
I got you.
So when you look at the interactions, there's basically 3 different things you need to talk about. Either talk about the characteristics of the thing crossing the interface boundary, what the systems look like, boundary, and the media involved. And so we agree on those.
Yes.
So it's really the performance pieces. Because any interface requirement really is a
That's correct.
rather than putting that same value in multiple requirements, we put it in an ICD.
Okay.
And so it's a lot easier to manage that, especially if there's multiple systems that may be pointing the same definition. They could get out of sync if you don't put them in one place.
Understand. I've been advocating the interface requirements because interfaces are part of the functional requirement. You have to,
So they
I've been advocating that we don't have separate interface requirements because the interfaces are part of the functional, the trigger and the output.
I agree.
Yeah.
And these requirements manual says that.
Okay.
But there's a separate section on interface requirements because they have a special interest when it comes to interacting with the outside world, other systems, how you point to the ITDs, the agreements, and how you manage them. There's a whole managing the interfaces the type of requirements that some functional requirements you're not.
Yeah, and in some ways, I agree that from a project management perspective, you have to treat them separately. I mean, we had to get multiple parties to agree to these.
So I think we finished complete. Feasibility, the need within the entity constraints, for example, cost, schedule, technical, legal, ethical, safety, risk. And this is the one risk that's bothered me the most, because from analysis for feasibility, how do you know it's feasible? And so that's where this whole concept of defining requirements is not exercising writing engineering and then actually do that analysis. So there's little point in agreeing to an obligation for a needed requirement that's not feasible, agreeing to a needed requirement that cannot be realized with acceptable risk within constraints, often results in project cost overruns and schedule slips. And especially if you think about a contractor supplier, now I've got all kinds of contractor issues. If it's fixed price, that supplier sure is accepted a whole lot of risk if they haven't done that feasibility assessment. If it's cost plus, then the customer is just a whole bunch of risk. If it's cost plus done by anyone outside the government.
I don't know about that either. We certainly would cost plus.
Inherently unachievable needs and requirements such as 100% reliability or at best a waste of time and worse lead to needlessly expensive solutions. One of the things you talk about decimal numbers, the more decimals you have, the tighter the tolerances are, the more expensive the design, plus the more expensive the verification you met the design. It could be not feasible within cost and schedule because of that. The need requirements considered feasible if and when considered along with other needs and requirements for a single system element, it does not cause the unacceptable cost, schedule, or risk impact during the entity's life. The requirement cannot be satisfied because it breaks laws of physics, violates laws and regulations, conflicts with other requirement, or cannot concur, or leads to excessive program risk because of maturity, inadequate margin into the respective program cost, schedule, or as a function lifecycle phase. And the feasible needed requirements neither verifiable nor correct. So feasible implies existence of a possible solution to satisfy that requirement. That's why it's so important that we do that up front. Concept analysis, maturation. Determine whether needed requirements feasible, difficult without underlying assessment, like I said. Useful tools, technology readiness levels. How many have heard of technology readiness level? TRLs are a scale of 0 to 9. One is someone wrote a paper, and then you start doing some work and some building some breadboards and brass boards and stuff, and then you work at building something, and then you start integrating it into its operational environment. And 9 is something that's routine use in that operational environment. The thing is the lower the TRL, the more the uncertainty is that you're going to be able to mature it sufficiently. And so the Government Accountability Office is still on a government program that don't even consider technology for use if you're not at least TRL level 3. And you have to have a maturation plan such that you're TRL 6 before you get to PDR.
So I have a question. The TRLs, is there an official definition for each of the levels?
Yeah, yes, over and over again. And there's a generic one. NASA has its own flight systems.
Right.
So the medical world
Okay.
has their own for medical what it means. And then like he was talking, there's also integration readiness levels, manufacturing readiness levels. So the whole concept is, that's risk.
So one of my projects has to meet TRL level 7. I find the official definition from the Air Force perspective.
You can?
No. It's only the
TRL
NASA
7?
Yeah, I can only find the NASA version. There's
So
one.
you went to the Defense Acquisition University website?
No, I didn't go there.
I think there's a guide out there.
Go to the Defense Acquisition University, DAU's website, then you're going to get the military definitions.
Okay.
There are lots, I think. They're all very similar, though. I think there's a NATO one. Any of those standards bodies tends to have a TRL. But as Lou said, they go from 0 to 9, and they've got levels of technical maturity in there. So you can choose any, but they're all very similar. But there are a number.
The Government Accountability Office has a document called Technology Readiness Assessment. It talks about how you do it across the life cycle. It has the definitions in it.
Okay.
That might be a good place. Another use is advancement degree of difficulty. It's one thing to say you're a tier level, and we talk about risk, but what's it going to take to go tier level 3 to 4? How much time and effort is it going to take?
Yeah, I've seen a few papers on that.
Assessment of feasibility part of life cycle concepts and needs definition activities before defining the design requirements. If your needs aren't feasible, your requirements transform them aren't going to be feasible. So we need to address that early. Other useful tools include modeling and prototyping. You can build a model of something, and I'm not talking about system model, or building a prototype. Architecture and design people must be involved from the beginning. The reason for that is a lot of TRLs in the world, the physical world, the technology. And so the design teams want to pick the station. So they're the ones that are best to get in critical technologies. And then once you know the critical, you can ask certain questions and see what your TRL level is. Feasibility, individual need statements can also be assessed during early system verification. Before allowing a need into your set, an assessment of feasibility of the chosen lifecycle concepts must be made in terms of drivers constraints, including maturity of critical technologies, cost, schedule, resources, regulations. The measurement of feasibility is not always easy to assess because there's always a degree of risk associated with it. And that's one thing TRLs is about, is the lower the level, the higher the risk. The higher the TRL level, the lower the risk of the project. One thing I like is needs and requirements feasibility bucket. Part of the analysis we go through before we put any need or requirement into the set is we go and do this feasibility. Can we do it within cost, schedule, technology? And then you have risk. Can we do it with an acceptable amount of risk? GAO says that if it's less than 3, the risk too high, don't do it. We've seen too many failed projects. We have rules, a set of attributes that we talk about that helps establish that characteristic. Taking ahead of system verification validation, if you can't define the success criteria and the method, your approach for how you're going to verify the system met that, then maybe it's not feasible. A lot of the activities, we talk about technology maturity. And then we have verifiable, validatable. We add the validation there, so we're covering both needs and the requirements. Unless a need statement is written in requirement validation, design validation, system validation, there's no way to tell whether it's been satisfied. So remember in context, so requirement validation is validating requirements against the needs. Design validation is validating the design against the needs. And system validation is validating the system against the needs. Each needs must include the necessary information such as validation success criteria and safety to be defined. The system to be validated so sufficient evidence can be gathered to determine whether or not the success criteria has been met. And there's no ambiguity regarding what the need statement communicates, and there are no missing characteristics with the need, and it's conforming and complete. Unvalidatable need can result in multiple objective observers, for example, architects and designers or testers, interpreting the need differently, making it difficult to validate their design, and system interest means the need. Unless a requirement statement is written in a way that allows design verification or system verification, there's no way to tell if satisfied. Each requirement statement must include necessary information, such that verification success criteria. So the same kind of things I said about the needs. Verifiability, validability is necessary condition for establishing appropriate, ambiguous, and these other characteristics. Verifiability, validability should be assessed when you write the need requirements. This is verification validation context. You just say we're doing verification validation. I'm going to ask you, what are you verifying validating, and what are you verifying and validating that thing against? So we're really sloppy in that. I went to an organization and interviewed different levels and different people individually within the organization. One of the first questions I asked every one of them was define verification validation. And with that same organization, I got multiple answers. Notice all the boxes on the bottom. Again, those are requirements on the organization involved information. So those are just as important. In reality, we're always doing a transformation based on 2 sets of requirements. The blue box path, and then also the yellow box path. And I use the word design controls. They're part of a larger quality management system that's defined by the FDA. there's actually law that any company that's building a medical device has to have the design controls for each information. And if you don't have those, you can't show that you met them, the FDA won't approve it. You get what they call a 483, which is their discrepancy reports that they issue.
So then what are the yellow boxes?
The yellow box, like I said, those are the organizational requirements on processes. Notice that each of the transformation goes up is on the transformation itself, which is performed by people.
There, on how you work the process, not added to the products.
Well, not necessarily. So an organization that builds a whole series of different kind of things, and they found through the School of Hard Knocks, lessons learned, good and bad, and they document those lessons learned, and then they develop their own standards, if you will, within the company, so that they don't repeat past mistakes. And so that's where I said JPL has a document that they capture all that into called design principles, and Goddard, they call those gold rules. I've brought that up to a lot of companies, and they give me the deer staring in the headlights thing. You mean as a company, you don't document your best practices? You don't document your lessons learned? You just repeat the same over again? You know?
Lessons learned can be very embarrassing
Yes,
to the organization.
lessons not learned in a lot of cases. Okay.
Yeah, I think quick comment. So in med device companies, it's pretty specific. I have seen the documentation where the requirements are mixed up. The set has both product facing and the process and people facing. And I have in the past, because for the exact same reasons, because those yellow boxes, do those documentation go through the approval cycle of review, approve, and release in your QMS, or are they uncontrolled documents of lessons learned, which is more organization facing, but at the same time, if we don't make them accountable, then do people actually follow that or not? Was another question. But the blue boxes, yes, everybody has to. So
The one about the system realization, the FDA is pretty big about that, because that's your production. Are you producing a product repeatedly? They're really big on that.
So the organization should be heavily involved down at that bottom line.
Title 21-820 defines the system engineering process. It talks about design inputs, design outputs, it talks about needs, it talks about your reviews and how you document your evidence.
But your quality assurance would be looking to make sure you were following those processes.
And so when you look at PMI, the Project Management Institute, a lot of what we talk about are system engineering tasks and verification validation. And PMI, they're under the quality function. Medical device companies, there's ISO standards for the quality management system, and there's ISO standards for each of these yellow boxes.
Right. So just one last question on the far right, the organizational events and disposal requirements.
Right.
Comes in after you realize this is not too late.
That's where you've done your instructions for use based on built.
But if your maintenance and disposal requirements derive changes in, you now have it after the realized system of interest.
So you're thinking serially, again, think currently. You're right. When it comes to having certain maintenance requirements on how often do you have to clean something, how often do you have to lubricate something, part of that is a function of the design. If I design a spacecraft to last a certain lifetime, I can't go up there and maintain it.
Right.
But ground systems, I can maintain it. So that's where the mean time between failure kind of stuff comes in, mean time to repairs come in. And so that drives the design. And then the organization is going to put together a maintenance procedure, or if it's like software procedure, how do you update software?
So that box is what you do with the system of interest now that it's designed with respect to the maintenance disposal.
Right.
Okay. But hopefully you've got your maintainability requirements in it. And
Oh, definitely.
disposal requirements of that, so you're not using stuff that goes in.
Yeah. So all those stakeholders were involved in the upfront process.
Okay.
They drove the needs and requirements. So the maintenance tech says, what do I need from the system up front? And if that involved design of the system, then we designed it. verifiable, validatable. It's really about design and system verification against the needs and the requirement design and system validation. We want to make sure the requirements can be validated against the need, the design can be verified, validated, result in the system that meets the needs, and realized system can be verified, validated, requirement needs. Write each requirement need statement in a way that allows the design or system to be verified, validated. So again, we're saying when you're writing the requirement, think ahead to verification validation. If you do so, then it's going to help make sure all your needs and requirements are verifiable. Verification validation point of view, and whether this validated against the requirement need to be assessed again during early system verification activities. So as a recommended best practice, define the verification validation criteria, strategy, and method. And once it's done, the quality of your requirements are going to improve because you've assessed that early. And this is one of the figures that's in section 10 of the needs and requirements manual that shows it's not just simple definition of something, there's a thought process that goes through. I have a need and requirement statement. Each of those represent a verification validation instance. So I want to define the success criteria, which informs what strategy I'm going to use, which informs the method I'm going to use. But then it doesn't come for free. So now I've got to do a cost, schedule, risk, and confidence level. And also what kind of enabling systems are involved in doing that. And I have to assess feasibility of going that way. And it may be that it's feasible and fine. If it's not feasible, then I have to rewrite the requirement. I have to define different success, find a different strategy, use a different method. I was going to do tests, but it was too expensive, so maybe I'm going to do analysis. But then, what does that do to my risk and confidence level? So I got to trade all that off, because if I could do a test and I didn't do it, my confidence level is going to be lower.
Right, so the test is your highest level of confidence.
And that's what really bugs me when people say, oh, we don't need to do verification validation on the physical system. We could use our system L model. So you heard that?
If this were to be a software requirement, I have seen in some places they immediately default to user stories, and they derive it from the user stories to get to the verification, and towards then they tie it back to the requirement. Have you seen examples of that?
Yeah, so the user story to me is the source of my needs and requirements.
That's how I understood it, but
Yeah.
in software world, it's a different thing.
They just like to do without requirements, period. So to them, a use case is a requirement, and it's a need all at the same time. And they don't think about verification like the way we do. They just say, we're going to run a test case. And we want automatic test cases. And they ignore what really verification validation is against specific requirements and validation. So there's a clash of cultures between the two worlds.
Details about what they said makes up a quality use case. It really close to what just needed for a quality requirement as well. I mean, you've got to have the function or the characteristic, you've got to have the triggers or conditions, whatever that requirement is against, you've got to have those same use case, to have a quality use case.
When it comes to that set of requirements, I find that most of the system, the software are lacking.
Yeah.
They focus so much on functionality that they ignore everything else.
But they're agile.
They're actually, don't have to do that. Section 10 and 11 goes a lot concerning this. Rules, attributes, a lot of activities have to do with verifiability, validity. And so that ends that segment on characteristics of individual and requirement statements.